Good afternoon, everybody. I'm Rajesh from Cisco Systems here, presenting on our one of the innovative product we have done in India, and that's the Nexus 3000 series of our switch data center switching, which is catering to some of the telecom and large service providers data center infrastructure requirements. So Nexus 3000 nomination, of course, that's what I'm here for. So we have this Nexus 3000 series where we have multiple product lines meeting various requirements of the various telecom or service providers. And these are four main product lines within the 3000 series, depending upon how many ports and what is the speed of various ports ported on those products. So we have 1 gig, 10 gig, 40 gig options. We have 10 gig, 40 gig options on particular SKU, or we have 100 meg, 10 meg and 1 gig options on some SKUs, and we have some fileless 1 gig, 10 gig and 40 gig on one SKU. So there are various formations of typically the same innovation in infrastructure within the SKUs, but meeting different requirements of various small or big or medium size service providers, data centers. So this is primarily targeted for the data centers of the telecom and service providers. Here's a brief product overview. As I said before, this is called Nexus 3000 series. It's pretty much very high performance, high density, ultra low latency Ethernet switch that is part of our bigger Nexus 3000 series switches. It's a compact 1 RGU form factor switch, provides the line rate L2 and L3 switching at the various speeds starting from 10 meg all the way up to the 40 gigabits per second. It's totally standards based technologies, no Cisco proprietary standards, compatible with all the RFCs and all the industry standards, and one of the major factors is totally developed and driven from India team in Cisco, Bangalore. So touching on the infrastructure requirements of the various service providers, this is the typical scenario where normally a service provider's data center is deployed in a small scale data center. If you see that normally you have a VPN through the clouds, going through all the way to the data center of the service provider, going to the network fabric, and ultimately leading to all those servers and switches. So typically this Nexus 3000 is targeted at the top of the rack switch connected to all the servers in the typical service providers data center and telecom service providers. So that's pretty much close to the large scale deployment. Is slightly different in the sense that they typically use VRFs at the cloud edge for each of the customer. This is one typical scenario, and again this particular product is targeted at the top of the rack within the data center servers. I just briefly going through them so that I can provide you the context of this particular infrastructure in the telecom. As I said, some of the key innovations in this direction are ultra low latency switching, which is very critical for those telecom service providers because of all these cloud and virtualization requirements. And ultra low latency is one of the key driving factors behind this, which is here we are talking about latency in sub microseconds. Our switch provides the latency somewhere around 400 nanosecond to 1 microsecond depending upon the various configurations and the various packet sizes. Performance is another key innovation in this product. First time we are providing the line rate switching capacity for L2 L3 packet up to the 40 gig as well as the 10 gig links. Intelligent enough, we have enough software features. I will be touching them down the lines. And of course this is based on the Cisco's industry proven NX OS operating system, which is already proven itself in terms of its high availability, security and QoS and management abilities. This is based on the same operating system. This is a typical picture of the front and back. Front panel is pretty much crowded with all the interfaces. Gig interfaces always 10 gig as well 40 gig interfaces. On the back panel side we will have this redundant power supplies and hot swappable fans and all those console or management interfaces on the right side of the panel. Going one level details of the product line. So these are typically four variations. I briefly talked in the beginning. The difference is only in terms of the interfaces. Some of them starting with 10 meg, 100 meg, 1 gig. Some are going up to 40 gig. So that's the only difference between these products. As I said, these are the typical innovation highlights. Less than 1 microsecond. Our latency is in nanoseconds. It's one of the first service provider data center wire rate 40 gig switch. That's one of the things happening its first time. And of course developed and fully driven from India Cisco Bangalore office. It's a completely owned, architected, driven and developed here in India. We have very highly scalable rich L2 and L3 features for massively scalable data centers, which is one of the key requirements for the telecom service provider as they will be growing their business. I'll be touching on those features down the line. Some of the power on auto provisioning are some of those highly required features for all these service provider data centers. L2, L3, IP4, V6 switching and routing at line rate. That I will be touching more on this down the lines. 1.2 terabits per second of switching routing capacity at the line rate. That's the total capacity of the whole system. That's the maximum line rate switching capacity. That itself is innovation in this product we are doing. And one of the very critical hardware level feature requirement is precision time protocol, which is very critical for service providers in the data centers again. Based on the IEEE 1588 standard, of course, everything we have in this product is all standards based, nothing proprietary. Touching on the some of those things I said, there are different form factors. Interfaces we are supporting and the typical scenarios where how they are deployed by the customers. In this one, I think the service providers is mainly on this first line, the blue one. Those are the main interface requirements coming from the telecom service providers. Touching on some of the hardware technical specifications, we have 48 fixed 10 gig Ethernet HFP plus ports, 4 fixed QSFP plus ports. Each QSFP plus port can be used as 4 times 10 gig interface also. 2 AC DC power supplies in the redundant mode, so that high availability of the power is always there. 4 fans in 2 trays, stacked fans in a single fan tray. Embedded USB, and of course in interfaces we have console ports, external USB port for various purposes, ultra low latency, less than 1 microsecond is normally the standard. Line rate switching on all ports irrespective of the number of ports in the switch. Continuing on the data plane side, of course we have overall capacity of the data plane is 640 gigabits per second, and that means we have 64 line rate 10 gig ports which are switching the traffic at the line rate. Switching to the software feature sets, this is the kind of summary of the lot of features we have. All layer 2, layer 3 manageability in QoS and system operation features. I don't think I have the time to go through each of them, but point I'm trying to make is that we have a super rich set of features required by telecom service providers to meet their various deployment requirements as well as the customer management requirements. It will be touching on layer 3 routing capabilities. Of course, we support all these features, major features like unicast routing, multicast routing, and various kinds of L3 interfaces, security and segmentation requirements, and QoS, and the list goes on for sub features within these primary main features. Again, this slides here highlights some of the sub features within the major features we are supporting. I guess the point I'm trying to convey here is the feature richness is one of the differentiator here in these our products. So some key differentiation, of course, scalable feature is L2, L3, ultra low latency, wire rate suite for the 10 gig, 100 gig, all the interfaces, very low power consumption, very identical architecture for all kind of interfaces, and PTP is one of our high standards. I will try to skim through some of these performance scalability numbers. Basically, they are meeting and beating all the large scale service provider telecoms data center requirements. And the QoS aspects, in the interest of time, I am trying to skip some of them because basically we have very feature-rich product which is meeting all requirements irrespective of the size of the telecom service provider. Thank you. That's all. And questions, please.
When have you made this product commercial? Number one. Number two, which are the competing products in this space?
Okay, so the question number is when we are making this product commercial. So the first version of this product is already commercial last month. We released the product last month. Question number two is who are the competitors with this product? Okay, so I mean I can name the competitors from the company's point of view, but
I mean competing products. I'm not saying which competing companies. Of course, those products will belong to some companies. If there's an innovation and somebody has to benchmark it against the other products.
I see.
Right. So what are those products which will be competing with your product?
Yeah. So based on my knowledge, of course, we are the first one with this super set of these features and this hardware low latency and the port density as well as switching capacity. I don't think there is really a competitor, but in terms of the companies which are coming up with the products which are competing us in these market segments are like Juniper, Arista, are the two main companies where I'm hearing that they are trying to bring up a product which is going to be very close to our product. Yeah. Thank you.
Thank you.